So the first question, which unit is not an SI base unit? So amperes is a unit, is a base unit, kg is a base unit, coulombs is not a base unit, right? Charge is not a basic quantity, so its unit is also not a base unit. Question number 2, what is the best estimate of the number of atoms in a piece of metal of volume 50 cm cube? So now this is a slightly, I would actually go on to say this is a difficult question. So you have to estimate the number of atoms in a piece of metal of volume 50 cm cube, right? So the first thing that you have to identify here is that the diameter of an atom, the diameter of an atom is of the order 10 to the negative 10 meters, right? Again, you don't have to work with exact values, and again, if you do know this from chemistry as well, so this is just an estimate, because for each of these actual particles the diameter would vary, so this is just an estimate that we have. So for 50 cm cube, what would be the number of atoms, right? So if I think about this being the diameter of each of these atoms, so again I know that the volume of a sphere would be 4 by 3 pi r cube. But again, if I am going forward with this idea that it is in fact an estimate, I can choose to omit all of this 4 by 3 pi and just work on this. If this is 10 to the negative 10, so if you guys also remember your math, so this would be 10 to the negative 10 raised to the 3, which is really going to be 10 to the negative 30 meter cube, right? So the diameter of one atom, so basically one atom has a volume of this much. Now this is meter cube and also this is centimeters cube, right? So 50 centimeters cube would be 50, and 1 centimeter is 10 to the negative 2 meters, right? So this would be 10 to the negative 6, again because of the cube. So if I look here now, I would say that if one atom, if I just make a simple unitary method column like this, if one atom has a volume of 10 to the negative 30 meter cube, how many number of atoms n have a volume 50 into 10 to the negative 6? And here on out, this is just simple elementary level math. You just cross multiply here. So n basically is 50 into 10 to the negative 6 over 10 to the negative 30, right? So this becomes 30 minus 6, so it becomes 24. So 50 into 10 to the 24, which if you look at the above options, this corresponds to 5 into 10 to the 25, right? So the answer to this one is B. All right, so that's how you do this one. All right, next, a copper pipe has a true diameter of 48.03 millimeters. A builder measures the diameter of the pipe 5 times using digital calipers. Measurements are shown. What describes the builder's measurement? So you have 48, 47, 48, 48, 47. So you can see that because all of these are very close to each other, I would say these are precise. But because it's very far away from the actual value, this is not accurate. So precise but not accurate. Option D is what we're going for. Two forces each of 10 Newton act on a point P as shown. Angle between the directions is 120. What is the magnitude of the resultant force? Again, with resolution, there are a lot of ways to do this. For example, if I just make an imaginary line here like this, I can say that basically if this angle is 90, because that's the idea of resolution, when you break up forces into perpendicular components, I can say that 120 minus 90, this is 30, right? So I can say this component of this force is going to be 10 cos 30. This is going to be 10 sine 30. Right, so 10 sine 30 is 5, and 10 minus 5 would mean this is like 5 newtons like this. And I don't have my calculator, so I'm relying on you guys for this, but I'm pretty sure this is some value like 8.66 newtons, right? And then you just use your Pythagoras theorem to find out this thing here, right? So you can just do this. Alright, so when you work this out, the resultant turns out to be 10. Again, not really difficult. Let's go here. This is slightly more technical as a question. One object moves directly from P to R. So one object just goes all the way like this. In a shorter time, so it takes less time now, a second object moves from P to Q and then Q to R. So this one went like this one went like this, and then like this. And across this one, the time was less as compared to what it was from directly P to R. This statement about the two objects is correct for the journey from P to R. Can they have the same average speed? Because if you think about the average speed is total distance over total time. This one does some distance. This one obviously does more distance, but in less time. Its average speed is going to be greater. If I just write this out, average speed is total distance over total time. If I talk about the journey in green, it covers more distance, obviously, because it goes through more of a length, and it also takes less time. So overall, the average speed is going to be greater. So this cannot be the case. Do they have the same average velocity? Now, with the average velocity, how the formula is different is that this is total displacement over total time. So I know that the displacements are the same, but because, again, if I'm talking about the green journey, so it did take less time, so it would have a greater average velocity. So this is also out. This is correct. They do have the same displacement, but they do not travel the same distance. All right? I mean, it makes sense if you look at the options. It does make sense as to why C is the correct option. But remember that a good A and an A star candidate knows why the correct options are correct, and he or she also knows why the other options are wrong. So I'm just explaining to you guys why the other options are wrong. Alright, question 6. A ball is kicked so that it has an initial velocity of... So a ball is kicked so that it has an initial velocity of 12 at an angle of 50 degrees to horizontal ground. Assume that air resistance is negligible. What is the max height that is reached by the ball? So again, for max height, because we're talking about the vertical height, that's the component we need. In this case, it's 12. And since this component is not with the angle, this is sine 50. So if I think about the equations of motion, I know u is 12 sine 50. For the max height, the idea that you need to remember is that the vertical component of the velocity is 0 here, right? And acceleration is negative 9.81. Why is this negative? Because I'm doing this, that I'm taking vectors downwards is negative, vectors upwards is positive. So if I've taken this as positive, this one is going to be negative, right? And I need what? I need the height, which is s. So it does make sense as to why we're going to use this equation of motion. So you have 0 equals to 12 sine 50. Again, what does this turn out to be? Let's see. So 12 sine 50. Alright, 12. What? So this is 9.19. This will be squared plus 2 times negative 9.81 times s, and from here you just solve for s, right? So the answer should turn out to be C, 4.3. A camera drone of mass 1.2 kg hovers at a fixed point above the ground. The drone has 4 propellers. In a time of 1 second, each propeller pushes a mass of 0.4 kg of air vertically downwards. Alright, now let's read the statement again but slowly. In a time of 1 second, each propeller pushes a mass of 0.4 kg of air vertically downwards. Assume that the air above the propellers is stationary. What is the speed of air leaving each propeller? Now, if you guys were with me in the P2 revision session, then you might remember that I told you a formula for the mass flow rate, which is rho AV. But if I think about this, and first of all, why did I think about this is because I see 0.4 kg in 1 second. So this really becomes 0.4 kg per second. But then I think about it, so I don't know rho, I don't know A, I don't know V. So it's not really something I can use here. Instead, what if I think about momentum here? Because this camera drone is at a fixed point above the ground, right? So what's happening here is that this is propelling each propeller is basically propelling air downwards. So all of these are pushing air downwards through all of these fans. By Newton's third law, if the propeller pushes the air downwards, the air pushes the propeller upwards. And both of these forces are equal and opposite. So as a consequence of this air being pushed downwards, so the propellers are being pushed upwards, why is it not going up and why is it at a fixed point above the ground is basically because of its own weight, right? This is why this value is given. So there is this weight of the propeller. All right. So the weight here must equal this force which is exerted on each propeller. So I'm writing this as 4 times the force on each propeller. All right. Now, if I look here, W is just going to be mg. So 1.2 times 9.81 equals to 4 times the force basically on each propeller. So for each propeller, what do I know? I know that 0.4 kg is propelled each second. So now I'm thinking about using this equation, F equals to delta P over delta T, which I know is written as delta mv over delta T. What I have in this case as 0.4 kg per second is really delta m over delta T. So I have that as 0.4 and I don't know the velocity here. And now I can solve for the velocity with which this air is basically being propelled, and that is what my answer is going to be here. So 1.2 times 9.81 divided by 1. So this is what the answer is supposed to be. All right. Something else on Newton's third law as well. A box rests on the earth as shown. Newton's third law describes how forces of the same type act in pairs. One of the forces of a pair is the weight of the box, which arrow represents the other force of this pair. So remember this idea, and I've talked about this previously as well, that when you talk about Newton's third law, there are a few similarities and there are a few differences between what we call the action-reaction pair. So the similarities are that both of these are equal in magnitude, and also both of these are the same type of force. So if one of these is a frictional force, the other one is also a frictional force. If one of these is a reaction force, the other one is also a reaction force, right? And similarly, if one of these is a weight, the other one is in another way, is in some way also a weight. The idea is this, that because both of these masses attract each other, so the weight is nothing but the force of attraction the earth exerts on the box. So the other one must also be some type of force of attraction. And the differences between them are obviously in the direction, and the other difference is in terms of the body which this acts on, right? So if this force W is what the earth exerts on the box downwards, the other force must be what the box exerts on the earth but upwards. Hence, the answer is A. The most common misconception here in this case is to say that W and B are action-reaction pairs. Are these forces equal? Yes. For this to be stationary, they must be equal. For example, if you are sitting on a chair right now, the weight and the contact force that the chair exerts on you are equal. Are they equal? Yes. Are they opposite in direction? Yes. But do they act on different bodies? And the answer is no. This cannot be an action-reaction pair because both of these forces are acting on you. So they must act on different objects. So it's A on B, B on A. Earth on box, you just flip those order around, and now it's going to be box on earth. Alright, this one. A small ball is held at the surface of liquid oil in a container. Ball is released from rest and falls through the oil. Ball has velocity v, viscous drag F acts on the ball. Which graph could show the variation with v of F? So basically this is the variation of drag with velocity, right? Now, I know that from my syllabus what I'm supposed to know is that any sort of drag force, it could be air resistance or just viscous drag, it's in a way going to increase with velocity, right? So that's all you are supposed to know, that as velocity increases, forces, the viscous drag also increases. Now I see that happening in A as well. What about B? Again, it's as the V increases, force increases, increases. But if you look at this small section here, again it seems really too small to notice, but between this part, it actually seems to be the case that as V increases, F decreases. This small portion is what disqualifies this option, right? In C, obviously, this portion is much more obvious, that as V is increasing, F is decreasing, wrong. D, V increases, F decreases, wrong. It should be increasing always. And it could increase in any way, but it should never decrease. So here the answer is A. Question 10. An object of mass m moving at speed u along a frictionless horizontal surface collides head-on with another stationary object, with a stationary object of mass 4m. After the collision, the object of mass m rebounds along its initial path with 1/4 of its kinetic energy before collision. What is the speed of the object of mass 4m after the collision? Alright. So this object of mass m rebounds with 1/4 of its kinetic energy. So I know this idea that kinetic energy is proportional to the square of the velocity. So for this to be 1/4, What must have happened to this? Remember, we've done very similar questions when we were talking about the relationship between intensity and amplitude. The idea is that whatever was the factor change in this basically got compounded because of the square, and that is what the change is on the kinetic energy. So basically we are looking for the square root of this thing, right? So the idea here is that this velocity must have become half of what it was. So after the collision, this object M is going to rebound with a speed u by 2. And you need to know now the speed of the object of mass 4m. What is this guy's speed? So now you use conservation of momentum. So total total momentum before equals total momentum after. So previously it's mu, right, plus 0 because of the 4m object not moving, and then it's going to be m. But because it's now moving towards the left, I again use a sign convention that right is positive, left is negative. So this is negative u by 2 and 4m times v. Any velocity, no matter how clear it is, or maybe even if the examiner has stated to you in the question that it's going to be moving towards the left, take it to the right and let the sign of your answer tell you where it is going to move, right? So this thing is going to be minus mu by 2. When I take it to the other side, this is going to be 1.5 mu equals 4 mv. M's cancel. So v is 1.5 u over 4, which is what? 3 over 2 over 4. So 3 by 8, right? So D. Driver of a car applies two parallel forces to a steering wheel as shown. Each force has a magnitude of 15, acts in the direction shown. Steering wheel has a diameter of this much. What is the torque exerted on the steering wheel? So this is very obviously a case of couples, right? So I just need to resolve these forces then. So this is going to be cos, 15 cos. This is going to be 15 sine, and obviously the same thing is going to be there on the other side as well, so I'm not doing this again. So the formula for the torque of a couple is force, so the force of any one times the distance between the two forces, so it's really 15 sine 65 times 0.4. Alright, so whatever this turns out to be is the answer for this one. So it must be D. This is the correct one. So next, question 12. A farmer is trying to lift the corner of a large water tank. She uses a metal rod as a lever. So this is the metal rod. Vertical force from the farmer is constant and is always applied to the end of the rod. Which change must increase the upward force on the water tank? So what increases this upward force? Right, so what increases this force? So as you guys can probably also see and visualize, there's this downward force which is going to create a clockwise moment here, and this is what is making the water tank basically lift up. Right. So what change must increase the upward force on the water tank? So again, must means there usually in AS, what this means in some MCQs is that there are changes here in which it could be the case that it's not necessarily an increase, and that will now become clear. Option A says using a longer rod and moving the pivot closer to the tank. So if you use a longer rod and you move the pivot closer to the tank, so if you move the pivot here, and if you use a longer rod, so now this is a case where obviously you have now increased the distance, because the force is always going to be applied on the end of the rod. So now the force is going to be applied here. So in this one, the moment is going to increase because you have increased the distance here, right? So in this case, the moment is definitely going to increase. This is the answer. Using a longer rod and moving the pivot further away from the tank. If you use a longer rod and if you move the pivot here, then the idea is then it depends on how much you move the pivot by. Because it could also be the case that the pivot is moved by a lot. And what happens is, for example, if you place your pivot here, now this distance is obviously decreased from what it was. So it could or it could not increase the moment. It depends on how much you change it by. Similarly, using a shorter rod is going to decrease the distance. Moving the pivot closer to the tank will increase the distance again. But again, you have no way of knowing what is what the overall change is going to be like. And if you look at D, this is going to decrease the moment in both ways, because you use a shorter rod, move the pivot further away. So in both of these cases, you are decreasing the distance and hence decreasing the moment. Question 13, the diagram shows a ball of weight W hanging in equilibrium from a string. The string is at an angle theta to the vertical tension in the string is T. Ball is held away from the wall by a horizontal force P from a metal rod. Which relationships between magnitudes of T, P and W is correct? Again, let's first do this for ourselves. This would also be theta, this one. So this is going to be T cos theta. This is going to be T sin theta. So obviously T sin theta must equal P and T cos theta must equal W, right? So T sin theta must equal P, T cos theta equals W, but I don't see this here, right? So what else can we do? What we can do is we can think of a vector triangle in this case. I see that there are only these three forces acting, P, W and T. So I know that if I talk about P and W, the magnitude of the resultant due to these two is going to be like this, right? This is the resultant of just P and W. And what T is basically doing is T is cancelling out that resultant. So I can make a vector triangle which looks like this then. So this is P, this is W, P, W, right? And again, just to make this fit as a triangle, let me make W here on this side. So this is P, this is W. Now you guys know that I would normally draw the resultant head to tail like this, but this is a vector triangle for a case of equilibrium. So I know the resultant is going to be like this. T is cancelling it out, so T must be in a direction like this. And this is still 90 degrees. So I can still see that P square plus W square must equal T square by the Pythagoras theorem. So the correct answer here is C. Which expression for pressure is correct? So pressure is very obviously force over area. Next. A ball has a mass of 0.5 kg, volume of this much. The ball is floating in equilibrium on still water. The two forces that act on the ball are its weight and the upthrust. Density of water is given. What is the percentage of the volume of the ball above the surface of the water? Also a good question, but definitely not the first time this question has ever appeared. The idea is weight equals upthrust, right? So here we have weight, which is obviously going to calculate it by mg. So 0.5 times 9.81, and upthrust is rho gv. So rho is 1000 as is given, g is 9.81, and again in this formula what v gives me is the volume which is below the water, right? Because upthrust only acts on basically the volume of the water which is displaced, which would only be displaced by whatever of this object is below the water. So 9.81 obviously cancels out. So 0.5 over 1000. So this is basically 0.5 into 10 to the negative 3 meter cube, which is what is below. So what is above? This is the total. So the rest of the 0.8 is above. 1.3 is the total, and you just multiply this by 100, right? So this turns out to be 62%. Always remember this. Upthrust and its ideas are definitely tested a lot in the MCQ parts. So do make sure you know this in and out. Question 16. A man sits on a buggy that is pulled along by a wire attached to a kite. The wire is at an angle of 40 degrees to the horizontal and has a constant tension of 200. Man and buggy travel a distance of 20 meters along a straight horizontal path. Wire and path of the buggy are in the same vertical plane. What is the work done by the tension force on the man in the buggy? Also not really difficult. You know that work done is the product of the force and the distance moved in the direction of the force. Here it's moving horizontally, so 200 cos 40 is the force, and distance it moves was given as 20 meters, right? So you just multiply the two together and you get the answer as B, 3.1 kilojoules. Next, 17, a ball is thrown vertically upwards from the surface of the earth. This statement describes the energy of the ball as it rises through the air. So definitely if it rises up, gravitational potential energy increases. So it's this, and as a consequence of the conservation of energy, the kinetic energy must decrease. The others are obviously wrong because GPE cannot decrease and total energy cannot change either. That's constant. Alright, question 18. A lamp is suspended in equilibrium from a fixed support by 3 long identical wires. Weight of the lamp causes each wire to have an extension of 0.4 centimeters. The height h of the lamp above the floor is measured. So this is above some floor. The middle wire suddenly breaks and the lamp falls a small distance as the extensions of the remaining 2 wires increase. The wire obey Hooke's law. When the lamp is in equilibrium, height of the lamp above the floor is measured again. What is the difference between the two values of h? Now this is also another question of this paper that was really tricky. The idea here being this, that if you look at this diagram, then the weight of the lamp is basically split between all of these wires. So if the weight of the lamp is W, then each of these experiences a force of W by 3. And this obeys Hooke's law. So 1/3 of the weight causes it to have an extension of 0.4 centimeters, right? With one of these now broken, there are only 2 left. And because of this, the weights that each of these will experience will be W by 2 and W by 2, right? Now, basically using Hooke's law, I can calculate what this new extension is, all right? I can just use the simple unitary method again, which is that if 1/3 of W, alright, let's just use the equation like this, equals K times 0.4. Actually, let's not even do this. Let's just use the unitary method. That's easier. So if 1/3 of W causes an extension of 0.4 centimeters, how much of an extension would W by 2 cause, right? So this becomes W by 3 Again, I just cross multiply for anybody who's wondering. So w by 3 times x equals w by 2. Let's do this here. W by 2 times 0.4. Obviously the w's cancel out. So x becomes 3 by 2 times 0.4, right? So 3 by 2 is what, 1.5. So the new extension is 0.6. So each wire extends by 0.6 now. So previously it was at 0.4, then it's now at 0.6. So how much does the extension basically decrease by? So how much does the extension increase by? Sorry. So how much does it increase by? So 0.6 minus 0.4, that's 0.2 centimeters. So 0.6 minus 0.4. Question 19, force extension graph for a spring is shown. What represents the work done? So work done is the area under the fx curve, right? So area, easy. 20, in an experiment, a student uses a mic and a CRO to analyze the sound wave. Diagram shows the trace on the screen of the CRO. The student is expecting a sinusoidal waveform to be shown on the screen. Which changes should the student make to the time base and the y gain of the CRO so that the screen shows a continuous trace for one complete cycle of the waveform? So as you can also obviously see right now, the wave is also going out of the screen like this. So you would probably want the wave to be something like this. So you must make the wave narrower. So to make the wave narrower, you should have it so that the time period, so if I just write down the equation, so the time period is time base times horizontal divisions, right? If you want the number of horizontal divisions to decrease, and obviously this is the time period of whatever signal you are measuring, so the time base must go up, right? So the time base must go up. This is the first idea. And how about the y gain? Again, for the y gain, I can do a pretty similar analysis. If I write it like this, that this is the amplitude equals the y gain times the vertical divisions. If I want the vertical divisions to reduce, the y gain must also increase. So increase, this is D. '21, the graph shows the variation with time of displacement of particle in a progressive wave. So this is a displacement time graph. So X is without a doubt, this is amplitude. Even in the case that this was a displacement distance graph, this would be the amplitude, and Y is the time period. So amplitude and time period, that's A. 22, a car travels at a constant speed along a straight line PQ. A loudspeaker attached to the car emits sound of constant frequency F. A stationary observer is at point O. What is the observer here as the car moves from P towards Q? So he's at O and it's moving like this in a straight line, right? And it's at it's at what? So it's constant frequency sound, right? And he's also moving at constant speed. So obviously we know that as he's going to move towards, the frequency that would be heard by this observer would be greater, right? Because there is relative movement towards the observer. So not A, not B. But would that frequency decrease or would it increase? Now again, this also requires you to understand something regarding how this is moving. So if I just make some lines here just to explain to you. So this is how this is moving right now with some velocity v like this, and this angle being theta, right? So if I think about the relative movement which happens here as he's moving towards, so there is this v cos theta here. Sorry, just a sec. All right. Sorry, not v cos theta. If this is how v, if this is what the speed of this object of this car is, what is this component with which it moves towards O, right? So if I now think about this, let's say this is, actually let's call this Vx, let's call this V, right? So I know that I would write it like this, so V equals to, sorry, Vx equals to V cos theta, right? This is how I would write it. And in this case, if I'm talking about V, so V would obviously be Vx over cos theta. Now I know this might seem a bit math heavy, but just bear with me for a moment. Compare this to a stage where the car is here. Again, it's still moving with the same velocity Vx like this. But as you can see here, this theta is now much larger. So what is, if this was V1, what is V2 going to be here? It's still going to be V, again, let's call this theta 1 as well. So it's still going to be Vx. So if this was V1, so this is going to be V2 equals Vx, which is still the same because it has a constant speed along this line, but it's now cos theta 2. And if theta goes up, as is going up here, cos theta goes down. So if cos theta goes down, the frequency really increases, right? So this is a frequency that is more than f, and it also increases here. This was the, alright, just a sec. Did I do something wrong here? Just a sec, guys. Alright guys, let's scratch this for a moment. It's definitely an easy approach which I forgot. Alright, so yeah, let's start with this line back again. So this is the line, right? The easy thing to do in this case, which would not involve the denominator, which is where I sort of went wrong, is if I think about it like this, that if this is the velocity with which it moves, and if this is the angle theta which it makes, I can break this down into components. I can say this is two perpendicular components like this, with this one being V cos theta. Alright? Again, V is the same, and let's say if this is theta 1, if I go on to another stage, probably something like this here, now my theta is obviously greater, and this would now be V cos theta 2, right? So theta has gone up, right? Theta 2 is basically greater than theta 1. And how the cost function works is now cos theta 2 would be less than cos theta 1. Alright? With sine, the greater the angle, the greater is also the value of sine. But with theta, the greater the value of the angle, the less is the value of cos. You can do this in your calculator right now. Do cos 20, do cos 70, and you'll find out cos 20 is more than cos 70. Right? So because cos theta 2 is less, right? So this velocity is also less as compared to what it was. So the frequency must also decrease, because the relative, the speed with which the source is moving towards the observer, this is decreasing. So the frequency would also be decreasing. Yes, thank you for whoever was there with the catch. Urva, thank you. Yes, C is the correct one. Alright, let's go on. So this was a really difficult question, by the way, as well. Some sources of EM waves in free space are listed. A radio wave transmitter, source of X-rays, a 30 mm wavelength radar transmitter, an LED that emits red light. So this is basically visible light. Radar transmitter, so by the way, this is really a 30 mm wavelength. Alright. So in this case, we would have to, if we just do standard form here, so 30 mm means 30 into 10 to the negative 3, right? And this is really, if I think about the order of magnitude just, so this is 10 to the negative 2. Visible light is 10 to the negative 7 meters. Source of X-rays, X-rays is obviously much, much smaller. So it's the smallest. And radio waves, if you remember, so radio waves have a wavelength which is somewhat like this, right? Radio waves is the longest wavelength. So increasing wavelength, right? So right at the end, I must have 1, so it's obviously C, right? So 23 is C. All right, another question. A vertically polarized beam of light is incident normally on a polarizing filter. Transmission axis of the filter is at an angle of 40 degrees to the horizontal. What is the ratio amplitude of transmitted to the amplitude of incident beam? Again, the light which is coming in is vertically polarized. This angle that is given to you is given with respect to the horizontal. Scratch that and think about the intensity which is coming in and what angle does the transmission axis make with that. So the intensity which is coming in is vertically polarized. The transmission axis is at some angle. This is what we're looking for. So the angle of interest in Malice's law is not 40, it's 50, right? And then it's also the ratio of amplitude, not the ratio of intensity. So I know that I equals I naught cos square theta. I also know this relationship that I is proportional to A square. So whatever is the ratio of the intensities, I can just square that and get the ratio of the amplitude, right? So transmitted to incident. So what's incident is I naught. What's transmitted is I. So I naught over I, this is really 1 over cos square theta. So in this case, 1 over cos 50 squared. This is what the ratios of the intensity would be. And for the ratio of the amplitude, which would be A naught, sorry, just a sec. I think I messed this up. Transmitted as I, incident is I naught. So this is I over I naught is cos 50 squared. So then by the same reasoning, if you do A over A naught, that's going to be cos 50 squared again. So it's really going to be cos 50 to the power 4. Right? So whatever this turns out to be is your answer here. So for 24, it must turn out to be C. Is that what we're getting? Amazing. So amplitude over A naught over A, because intensity is the square of the amplitude, right? So if you have the ratios of intensity, I made this mistake in saying this, that I over I naught, basically because of the square, is A over A naught squared. So if I need a over a naught, it's really going to be the square root of cos 50 square. So it's just really cos 50, right? So that's what it is. It's not going to be squared again, it's rather going to be square rooted. So 0.64 is what you should be getting. 25, two progressive waves meet at a point. What condition must be met for superposition? Superposition has no such conditions. The waves must just be of the same type, right? Anything else is not really a condition. Coherence is a condition for interference. Waves must be traveling in opposite directions is a condition for stationary waves. Waves must meet in phase is a case for a certain type of interference, a certain case known as constructive interference. Just superposition just needs waves to be of the same type. A string is stretched between a vibration generator and a fixed point. When the vibration generator is vibrating at frequency f, a stationary wave with 5 nodes is created on the stretched string as shown. Node at the end of the string is attached to the vibration generator. Frequency of the vibration generator is slowly increased. What is the next frequency that produces a stationary wave on the string? So this one is f, right? So it has node, 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 node. So this is half, 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 half. This is 2 wavelengths, right? And for this, the frequency is f. So if I think about this in terms of what do you call it? If I think about this in terms of the wave speed formula, so here this is f and lambda is basically it's 2 lambda. Sorry, not 2 lambda. If I think about this as being some length L, so you can see that if 2 lambda equals L, so lambda equals L by 2. So this is FL by 2, right? And then if you have another, what do you call it? If you increase the vibration frequency, so you'll have a new frequency. Again, you don't know this. This is what you want to find out. This new Fn, let's call it that. So now you'll have another loop added, right? So now it's going to be 2.5 lambda. So now if 2.5 lambda, or let's write it like this, if 5 lambda by 2 equals L, so lambda is really 2L over 5, right? So it's 2L over 5, so L's cancel out, and Fn, as you can see, it's going to be 5 over 4 F. Oh no. So Fn is now going to be Fn is going to be 5f over 4, which is 1.25. So it's 1.25f. No, I didn't. I calculated it above. See? I know for a fact that the next harmonic which is going to be set up is going to have another half loop. So the wavelength is going to be increasing by an interval of 0.5 each time out. Alright, so that's what I did. Again, if you have problems with that, just go through my video on stationary waves and the different cases and how they come about. A ripple tank and a barrier with a single gap are used to demonstrate the diffraction of surface ripples on water. Initially, wavelength of the ripples is 5 times smaller than the gap in the barrier, right? So this is much smaller than the gap. So wavelength is much smaller than the gap. Which change increases the amount of diffraction observed? You know that you have an increased amount of bending or diffraction when both of these are equal to one another or approximately equal. So you either want the wavelength to go up or the gap size to reduce. So wavelength to go up You don't see this explicitly, but it's really embedded into this option C, that if you halve the frequency of the ripples, the wavelength is going to go up by this equation, that if f goes down, lambda goes up, right? So for 27, the answer is C. All right, 28. A laser produces a beam of light of wavelength this much. The beam is incident normally on two slits that are this distance apart. So yeah, this is on double slit interference. So lambda equals AX over D. You're asked the distance, so you're really asked D. So D is going to be A times X over lambda. A is 0.12 mm. X is 7.5 centimeters, and divided by lambda, which is 650 into 10 to the negative 9. So this gives you D. So D turns out to be option D, 14 meters. A beam of light from a laser is incident normally on a diffraction grating. The diagram shows only the second order maxima that are produced. Grating has a line spacing of this much. Angle between this two second order maxima is this much. What is the wavelength of light? Always remember that in the diffraction grating equation, the angles are given from the center, from the central order maxima. So half of 110 is 55. So you use the equation d sine theta equals n lambda. So lambda is d times sine 55 and n is 2, right? So this is what the catch was here, and then you just solve for this, and this turns out to be option A in this case. Again, this is also not really difficult. Electric current is given, how many electrons pass a fixed point in a time of 10 hours. So you know current is rate of flow of charge, which can be written as NE over T. So N is IT over E. So current 4 milli, time is 10 hours, but again in SI units of seconds you need to convert this hours as well. So hours to seconds, so 10 hours, 60 minutes in each hour, 60 seconds in each minute. Divide by the charge of an electron. So this is what N turns out to be, and it should be C. Next, 31. What is the definition of potential difference? So either you talk about this in terms of the work done by a unit charge and going through a component, or in terms of the energy transfer. Here you have the energy transfer part, so you take that. So energy transferred per unit charge. Really straightforward. IV characteristics of a filament lamp. For a filament lamp, I know resistance increases, and in terms of a IV characteristic, the graph should bend towards the V-axis, and I see that happening in only D, right? A is how the graph looks like for a diode, right? And C is also sort of like a diode, and B is just a ohmic conductor, right? So B is really just a resistor in a way. A metal wire has a length of this much, cross-sectional area this much, resistivity is also given. So I have rho, I have L, I have A, so I can calculate R, right? The wire is stretched so that its length increases to 2.65 meters, and the wire remains cylindrical and the volume of the wire remains constant. What is the change in resistance of the wire? So R equals rho L over A. Volume remains constant, so this obviously means that that if the length increases, and I can think about volume as area times length. So if length increases, the area must decrease. right? So first, let's do this. Let's calculate the old resistance. So rho is 3.50 into 10 to the negative 7. Length is 2.5 and area is this much. Right? So this is going to give you some resistance value here. And then you know this resistance, whatever this turns out to be. Then you know that the length increases to this much and the volume remains constant. So using volume equals area times length, you first figure out the new area. So volume is still, so the volume you will have to calculate. So 2.5 times 4.5 into 10 to the negative 6. This is the old volume, should equal the new volume still with the length 2.65, and you want the new area, right? So this new area, what you then have, you then calculate R again. So 3.50 into 10 to the negative 7. Length is 2.65. Whatever is this new area that you have, and you just subtract the two. Again, this is a pretty calculator intensive question. So I don't have my calculator with me right now, but the answer should turn out to be this if you do this exactly like how I explained. Which circuit symbol represents a microphone? Again, this is just some stuff you need to know. This is a microphone, right? This is a loudspeaker. This, I'm pretty sure, is a buzzer, and this is a bell, right? So that's what each of these components are. 35, a battery with internal resistance is connected to a fixed resistor, ammeter, voltmeter is shown. Battery is replaced by a different battery that has the same EMF but a greater internal resistance. So this is larger. What happens to the readings on the ammeter and the voltmeter? So if you have a greater resistance, obviously ammeter reading is going to decrease. So it's A or B. What's going to happen to the voltmeter reading? So because this is now also taking up some share of the voltage, so this becomes a smaller fraction of the total. So by the voltage divider rule, this voltmeter reading is also going to decrease. So A. (36) 4 potential divider circuits, each consist of a battery of EMF 9 volts and negligible internal resistance connected to a combination of resistors. Each of the resistors in the circuits has a resistance of X or 2X. Which circuit has the largest output voltage? In this case, I can see obviously I have two equal resistors. There's a 9 volt. There's a 9 volt EMF. So across this, half of that, which means, so that means 4.5 volts needs to be appearing here. In this one, I would have to calculate using voltage division. So I would do 2x over the total resistance 3x times 9, which is going to be 6 volts in this case. Similarly for C, there is X and A, 2x in parallel. You might choose to do this, but you can also obviously see that if you compare both of these, 2x, and now imagine that the only change between B and C is now this X resistor in parallel. Because this resistance is in parallel, this is going to make the resistance go down, and hence also the voltage is going to go down, so it can't be C. And by the same reasoning, X and 2x, if you do this as well, in this case, if you do X and 2x, so let's think about this. So if you do 2x and x, so product over sum over 2x plus x is 3x. So this becomes 2 by 3x, right? So I'm looking at the voltage across x. So x over x plus 2 by 3, which makes it 5 by 3x, times the 9. So x cancel out. So this is 3 by 5 of 9, which is 0.6 of 9, and it's definitely not as large as 6. So the correct answer in this case is 6 volts. So 36 is B. A voltmeter is connected into a circuit with the polarity shown. The sliding contact is moved to end P of the potentiometer and then to end Q. What are the two readings of the voltmeter? So if this is moved here, right? So if the sliding contact of this is at point P, right? So what is the reading going to be in that case? Again, if you are just looking at this, so this means that with your contact here, all of the voltage, basically there's going to be this and this component in series, right? And so it really just becomes an application of KVL. So 3 volts must obviously appear across just the other component in the circuit, which is V, right? So it's either going to be C or D. And how about with the sliding contact at Q? So if I erase this for a moment, what's going to happen with the sliding contact now at Q? So with Q, if you look at this, if you look at both of these sources, so they are connected negative to positive. So both of these voltage sources are really adding up here, right? So this 3 volt is also going to be appearing plus the 3 volt, which is going to be appearing. So it's now going to be 6 volts. You guys, if you have practiced these older papers, then you might also remember this idea that when we have to use the null method with galvanometers, you always make sure that this EMF is connected to the same end here. This is not what we have done here, so the EMFs have added up instead of opposing each other, right? So 3 plus 3 is what happens here. 38 proton has mass this much, charge this much. What is the charge and mass of an antiproton? So same mass, but opposite charge, so D. A uranium nucleus has 92 protons, 143 neutrons. The nucleus emits a total of 3 alpha particles and 4 beta negative to form nucleus X. How can X be represented? So if I have 143, so the only change on the, again 143 is just the neutrons. So 143 plus 92, what's that? 143 plus 92. So I have 235 as my nucleon number. 3 alpha particles means that 3 times 4, this reduces by 12. So 235 minus 12 is 223. So it's either C or D. And now if I think about the proton number, which was 92, so because of the alpha particles, because we have 3 alpha particles, so it reduces by 6. But because of the beta particles, it increases by 4. So minus 6 plus 4, so just decreases by 2. So it's D. Last one, which statement about a proton is correct? A proton is a baryon but not a meson. So is a proton a meson? And the answer is no, because a meson is any one which has a quark and an anti-quark pair. So not a meson. Sorry. So it's not a meson, so it's not B, it's not C, it's not D. Obviously it is A. It is a baryon because it's made up of 3 quarks, right? So